Imagine waking up one morning, stepping out of bed, and instead of gracefully placing your foot on the floor, you just drift upward like a confused balloon. Congratulations! You've entered a world without gravity, and also probably the weirdest morning of your life. Don't worry, in today's video we're diving into how gravity actually works, why it keeps us from floating into space like lost socks, and what a falling apple has to do with a genius named Isaac Newton. Stick around, because by the end, you'll understand gravity well enough to casually drop facts in conversations and feel way smarter than you probably should. So let's start with the basics. Gravity is this invisible force that pulls things toward each other. I know, that sounds suspiciously like something your science teacher said, while everyone else was drawing Stickman on their notebook, but it's true. Everything with mass pulls on everything else with mass. You pull on Earth. Earth pulls on you. Technically, your chair is pulling on you too, but don't panic. It's not trying to start a long-term relationship. One of the earliest people to give gravity a serious think was Isaac Newton. You've probably heard the classic story. Newton was chilling under an apple tree, minding his own business, when an apple fell and bonked him on the head. Now, to be clear, like historians argue about whether the apple actually hit him or just fell nearby. But honestly, the version where fruit commits assault is just funnier, so we're sticking with that. Anyway, Newton sees this apple drop, and instead of getting annoyed at the tree or blaming gravity for ruining his day, he asks himself, Yo, why did that apple fall straight down? Why not sideways? Why not up? What's pulling it? And boom! This leads him to describe gravity in a way people could finally wrap their heads around. Newton's big idea was that everything with mass pulls on everything else. Big things pull harder, small things pull weaker, and the closer two things are, the stronger the pull feels. That's why Earth, being a massive chonker of a planet, pulls you down pretty strongly, and why you don't feel any noticeable tug from, say, a hamster. Unless it's a really determined hamster. But anyway, that basic concept explains why things fall, why the moon orbits Earth, and why we stay firmly planted on the ground instead of launching into space every time we sneeze. But wait, gravity gets even cooler. Fast forward a couple centuries, and here comes Albert Einstein, a man with hair so wild it could probably generate its own gravitational field. Einstein looked at Newton's ideas and said, "This is good, but what if I make it way more dramatic?" He introduced the idea that gravity isn't just a force, it's actually space and time bending. Imagine space as a stretchy trampoline. If you put a bowling ball in the middle, it sinks and creates a dip. Now toss a marble near it. The marble will roll around the dip. That's basically how planets orbit stars. In this analogy, Earth is the marble, the sun is the bowling ball, and the trampoline is your imagination, I guess. Stickman imagination. But here's the funny part. Even though Einstein's version is way more complex, the everyday stuff you notice, like dropping your phone and pretending it accidentally slipped, still works perfectly with Newton's simple explanation. So, for normal life, Newton is the MVP. Einstein just shows up when things get weird, like black holes, GPS satellites, and arguments on the internet. Now, speaking of everyday life, let's talk about how gravity treats us. When you jump, gravity pulls you right back down. When you drop your toast, gravity makes sure the buttery side hits the floor because gravity is petty like that. When you trip over nothing, gravity is there to yank you down dramatically as if it's auditioning you for an action movie. Gravity keeps planets in orbit, holds the atmosphere close to us so we can breathe, and keeps your drink in your cup, unless you're clumsy, in which case gravity is probably your arch nemesis. And here's a fun fact. Gravity is actually incredibly weak. Seriously. The entire Earth pulling on you is just enough to keep you on the ground, but a tiny magnet on your fridge can lift a paperclip against the pull of the whole planet. That's like a chihuahua winning an arm wrestling match against a sumo wrestler. Kinda humbling for planet Earth, but we don't bring it up. Earth is sensitive. So how does gravity change? Well, the higher you go, the weaker it gets, but don't get excited. You'd have to go really, really high before you could jump like a superhero. If you climbed a tall mountain, gravity would be slightly weaker, but Not enough to justify telling people you're technically a little lighter. They will, what about in space? People say astronauts float because there's no gravity, but that's actually wrong. Sorry to ruin that fun misconception. There's gravity in space. It's what keeps the moon orbiting Earth and Earth orbiting the sun. Astronauts float because they're constantly falling around Earth, not toward it. They're in a state called free fall, which is basically gravity pulling you down while your forward motion keeps you going around the planet. It's the closest humans get to feeling like a glitch in the laws of physics. So, to wrap this up like a very nerdy burrito, gravity is the invisible glue of the universe. It pulls apples down, keeps planets in line, makes sure you don't drift off every time a breeze hits you, and occasionally reminds you you're clumsy. Newton explained how it works on a basic level. Einstein explained how it works on a mind-melting cosmic level, and we all benefit from it whether we understand it or not. Thank you for watching this video. I hope you enjoyed. Please like and subscribe, it really helps me out a lot. And let me know down in the comments what video you would like to see next, and I'll see you in the next one.